In this video, we're covering the final part of the Algebra 1 end of course assessment practice test from the Florida Virtual Schools Practice Assessment. This is part 3, so I'm covering questions 41 through 60 out of this 60 question practice test. And of course, questions 1 through 40 were covered in parts 1 and 2. So let's go ahead and get started on these last 20 questions. For question 41, it says a wooden garden tray with a base area of xy square inches is filled with soil up to a certain height. The tray contains, and I'm going to just underline this expression here, cubic inches of soil. The height of the tray is represented by this expression here. Which expression below is the correct simplified form of the height of the tray? So if we notice here in our answer choices, we don't have any fractions. So this tells me that we need to simplify this expression by dividing. So you're going to have to use your exponent rules. And remember, when you're using your exponent rules, if you're dividing and you have the same base, what do you do with your exponents? Well, you're going to subtract. So if you're multiplying with the same base, you add your exponents. But when you're dividing with the same base, you subtract your exponents. So I'm going to break each of these terms up and divide each one by xy. Okay. So 10xy squared divided by xy plus 12xy divided by xy. And you could probably do this in your head, but I'm breaking it up so you can see what I'm doing. And then I'm just going to subtract the exponents here. So remember, if you don't see an exponent, there's an understood 1 there. All right, so I'm just going to go ahead and put 1s by all of my variables that do not have an exponent. All right, so now we're just going to subtract with the same base. So we have an x squared and an x to the first. We're left with just x, and a y to the first and a y to the first will just cancel out. So if I look at my answer choices, I could actually eliminate a and d because those are the only two with x. Now for the second one, 10xy squared divided by xy, I can bring down that 10. My x's will cancel out, and y to the second and y to the first, I subtract my exponent, so that would be 10y. And I can see here that my answer is going to be B, but let me just make sure here. Bring down my 12, my x's cancel out, and my y's cancel out because I'm subtracting my exponents. And so my answer here would be B because I'm just left with 12. For number 42, it says if x is not equal to 3, which of the following represents x squared minus 9 divided by x squared minus 3x in simplified form? So I can see I have some fractions in my answer choices here, and also x cannot be 3. So what I could do, I notice here that I have x squared minus 9 at the top. I could actually look at factoring that. That is a difference of squares. Remember, with a difference of squares, you have two terms, a minus sign, and they're both perfect squares. And so to factor that, you will take the square root of the first term and the square root of the last term and write it as two binomials like this here. So I factored the top. At the bottom, they have an x in common, so I could just factor out the greatest common factor there. So that would be x, and I'm left with x minus 3. And then I notice I have an x minus 3 in common. I could just cancel these out right here. And I'm left with x plus 3 over x, and that would give me D. Looking at number 43, it says which ratio represents the area of the smaller rectangle compared to the area of the larger rectangle? Figure is not drawn to scale. So remember, to find the area of rectangles, that's just length times width. And so it says ratio of the smaller to the larger. So my smaller area would be on the top. So that would be x times x plus 2. And then at the bottom, I would have 2x times x squared plus 5x plus 6. And what I'm noticing here, I'm noticing that my answer choices are actually factored here, and I'm given the top in factored form if I don't multiply it through. So I'm going to try to factor the bottom here. I'm just going to bring over my x plus 2. That's an x. And then let's factor what's on the inside of the parentheses at the bottom here. Two factors of 6 that have a sum of 5 are 3 and 2. So if I factor this, that would be x plus 3 and x plus 2. Can I cancel out anything? So that's what I'm looking for. I want to see if I could cancel out any binomials here. And does that match any of my answer choices? Not yet, because I have this x here. I can also cancel out these x's, right? So I'm left with nothing at the top, but I need to have a placeholder at the top. So I have to put a 1, because anything multiplied by 1 is just that term. And I'm left at the bottom with this 2 and this x plus 3. And so that would be B for this answer right here. Number 44 says, what is the value of x in the proportion x plus 8 over 5 minus 2 equals 3/8? Anytime you're given a proportion, you can always solve by cross multiplying. So that is what we're going to do here. I'm going to cross multiply. So x plus 8 times 8, I have to use the distributive property because I want to multiply the 8 by both the x and the 8. And the same thing here. 3 times 5x minus 2, I have to use the distributive property. So now I'm just left with the equations with variables on both sides. And remember that if you have x parentheses, you always want to use the distributive property to eliminate them first. So 8 times x is 8x. 8 times 8 is 64. 3 times 5x is 15x. 3 times negative 2 is negative 6. Again, combining my like terms, I'm going to actually subtract 8 from both sides. Normally, I would want to move my variable to the left-hand side, but I don't want to deal with negatives. If I were to subtract 15, I would be left with a negative 7. So I'm subtracting 8. That way, I'm left with a positive 7x. Bring down that minus 6. Adding 6. 64 plus 6 is 70. Bring down that 7 and divide by 7. So inverse operations, distributive property first. Remember, whenever you move anything across the equal sign, that sign changes. And so that is when I would do my inverse operations if I want to combine my like terms. And my answer is 10. And you could always check it. Let's go ahead and check it. So 10 plus 8 is 18, right? And then 5 times 10 is 50, and 50 minus 2 is 48. So 18 over 48, does that, if I reduce that, does that give me 3/8? Well, if I divide 18 by 6, I get, if I reduce this rather, I get 3. And 48 divided by 6 is 8. So again, if I just reduce the fraction, I get the same thing. So when you have equations, always go back and check your answers. So let's try another proportion here. Again, cross multiplying. 5 times 2x plus 3 is equal to 2 times 5x plus 3. Very similar. Distributive property, get rid of that parenthesis, those parentheses. 10x plus 15. 2 times 5 is 10x. 2 times 3 is 6. Combining my like terms, I'm subtracting 10 from both sides, and we're noticing that 10x minus 10x is 0. That cancels out. This would also cancel out on my right-hand side. I'm left with 15 is equal to 6. That is never true. 15 can never be equal to 6. So the solution to this equation is that there is no solution. So there is no real numbers for the solution for this equation. Okay, for number 46, we're looking at some radicals here that we need to simplify. It says, assuming that x is greater than 0, which of these expressions is equivalent to 11 times 245x to the third plus 9 times 45x cubed? And so let's start out by just simplifying each radical first. I'm going to bring down this 11 from the first one, and then we want to write this in simplest radical form. And so we have 245. Remember, if you want to write it in the simplest radical form, you want to find two factors of that number, and one of them has to be a perfect square. So what I would do, I would just, write your perfect squares on the side here. 1, 4, 9, 16, 25. And I'm generating them because I'm multiplying 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7. So that is how you generate your perfect squares. And then you will start dividing that number by your perfect squares to see which one divides evenly. And if I divide 245 by 49, I get 5. So 49 times 5 will give me 245. So I could break up 245 into 49 times 5. If I have an odd number exponent, remember with your exponents, the perfect squares have to be even, and you have to take half of it to get the square root. But since I have an odd exponent here, I'm going to break this x up into x to the second times x, and so I'm separating that so I could take the square root of x squared. Alright, so next, bringing over this 9. Two factors of 45, and one of them is a perfect square. 9 and 5. So one of my numbers that I break it up into has to be a perfect square, so I can take the square root of it. And once again, I'm going to break up my x, so I'm just taking 1 away. So anytime you have an odd exponent under your radical, subtract 1, so just take it away. And then you'll be left with the even number, and you could take the square root of that by taking half of it. Alright, probably should have wrote this a little further to the left, but I'll start over here. So I'm going to bring down the 11 from here. Take the square root of your perfect square. Let me write this in red so you can kind of see, or just a different color. I'm bringing down this 11, and I want to simplify what's under my radical. The square root of 49 is 7. So I have to bring that out. Since I have that 11, I have to multiply it by 7. Now I want to leave my imperfect squares under the radical. That 5 is not a perfect square, so it stays under the radical. This x squared is a perfect square. So I take the square root of x squared by just taking half of my exponent, or dividing that by 2. So half of 2 is 1, so I'm left with just the x on the outside here. And then this x will be left underneath. So I'm close to simplifying the first one. Okay, plus I'm going to bring down this 9 and the square root, simplifying my radical. And I probably should draw it a little further over. The square root of 9 is 3, so that 3 comes on the outside. So just like I took the square root of 49 and got 7, I'm taking the square root of 9 to get 3. This 5 will stay underneath the radical. I take the square root of x squared, which is just x, and look at me, I wrote it too close. So let me just put my x here like I have here. So I took the square root, and I'm just putting the 5 back where I had it. And then this is not a perfect square, so I leave it underneath the radical. Alright, looks like I'm going to have some like terms here. So simplifying a little more, I could multiply unlike terms. So 11 times 7 is 77x. Bring down at 5x. 9 times 3x is 27x. Bring down that 5x. And then I could add these two because they are like terms. So 77 plus 27, that gives me 104x. And I've already found my answer because I see it. And then because they're like terms, they are like terms because they have a square root of, not square root, yeah, square root of 5x. So I could combine them here. And so this is my answer for D, or for number 46, and the answer is D. All right, number 47, it looks like we'll still have to simplify some radicals here. So it says, assuming x is greater than 0, what is the simplified fraction form for this expression here? So I'm going to bring down a 5x square root of 3. I can't simplify that anymore. No perfect squares, no other factors there. But I see that I could simplify the bottom. So remember, simplest radical form, you find two factors of the number, and one of them is a perfect square. We would have to use 16 and 3. And we use that because 16 is a perfect square. 12 and 4, although 4 is a perfect square, it's not the largest one. You would just have to do the same thing again. So make sure you're choosing the largest perfect square. That way you're going to be left with a factor underneath that has a perfect square, and you have to actually do the problem again. So try to choose the largest perfect square, and eliminates a little work there. And I'm actually going to bring down the x squared. I don't have to break it up because it is a perfect square because it is even. So now I'm going to bring over the 5x square root of 3. And the square root of 16 is 4. And the square root of this x squared here is just x. I just take half of that exponent. And the only thing that's left under my radical would be 3. So now we can simplify. My 3's would cancel out, or square root of 3 would cancel out, and my x's would cancel out, and I'm left with 5 over 4, and I would just put it as 5/4 in my box here. If you're on a computer, you would just type it in as a fraction there, but my answer is 5/4. Okay, so let's look at number 48 here. Now we have some quadratics here. It says, which of these graphs show the quadratic function y equals 2x squared plus 8x plus 7? Several ways you can do this. Well, actually, we cannot factor this. I could solve this by using a quadratic formula. I don't want to do that because I think that would be too much work. So since I have graphs here, I'm going to actually see if I can find a vertex and see if the vertex matches in my graphs. So remember, the vertex is the highest and lowest point on the graph. So to find a vertex, that is just x equals negative b over 2a. And then you would plug in your x value to find y, and that would be your ordered pair. So remember, in a quadratic function, next to the x squared is a. Next to x term, or your linear term, is b, and c is your constant. I'm just plugging it in. So negative b, so that's negative 8 over 2 times 2, negative 8 over 4, and so the x value of my vertex is negative 2. So I can actually eliminate a, and I could eliminate d, because the x value of my vertex is negative 2. So I'm looking at, so these are my vertexes here, right here. All right, and then to find my y value, I'm just going to plug x back into this equation here. So just changing the color here. So y is equal to 2 times negative 2 squared plus 8 times negative 2 plus 7. Remember, if you're plugging in anything into a quadratic function, you're going to do the exponent first. So you're going to do negative 2 squared, which is 4, and 4 times 2 is 8. 8 times negative 2 is negative 16 plus 7. 8 minus 16 is negative 8 plus 7. So y is actually negative 1. So where is my vertex of negative 2, 1? And that is, or negative 2, negative 1, rather. And that is actually C. This is the ordered pair negative 2, negative 1. So I have found my match. So anytime you get in a quadratic function and some graphs, I think the easiest way would be to find a vertex. Also, you can do the process of elimination. If some of these graphs were flipped down, you know that this graph will flip up because my a is positive. So I've solved, or I matched the graph with this equation. Alright, so before I start number 49, I just want to say from the previous problem, you also could have looked at all the vertex for each problem and plugged in your vertex. So I'm trying to give you tips here. So I solved it by finding a vertex, but if you go through each one, if you cannot remember how to find the vertex of a quadratic function, look at each graph and look at the vertex on the actual graph. Get that ordered pair, and then just plug in x to see if you get the same y value. So just another tip on that one. All right, so let's go ahead and complete the number 49. It says based on the graph, we don't have a graph, but based on this, what is the positive x-intercept? We can actually find it. Quadratic functions, remember you could solve by using factoring, quadratic formula, completing the square, and graphing. So I'm actually going to factor this because I don't have a number in front of my x squared other than 1. And remember to factor. So this is a, b, and c. Why am I writing the parentheses so large? You find two factors of c that have a sum of b. So I'm going to find two numbers that when I multiply them, I get -3, but when I add them, I get -2. The only factors of 3 are 1 and 3, right? One of them has to be negative because this is a -3, and I want when I add it to be a -2. So that means that this 3 would have to be negative and the 1 would have to be positive, because I want when I add them together, I want to be able to get -2. All right. Now I could just set each one of these equal to 0 and solve. Subtract 1, so x is equal to 1. Add 3, x is equal to -1, not 1. Add 3, x is equal to 3. So it says the positive x-intercept is 3. And remember, when you're solving quadratic functions, the solutions are the same as the x-intercepts as well as roots. So quadratic functions, it has several terms for your solutions. So you have solutions, x-intercepts, as well as your roots. X-intercept is where that graph crosses the x-axis. All right, so for number 50, it says one solution of the equation 3x squared minus 16x plus 5 equals 0 is 1/3. What is the other solution? So again, this is a quadratic function. I could use the quadratic formula. Some students, they just use that to solve any quadratic equation because that's one way that you know you're going to get the correct answer. So you could use that. I'm actually going to factor this using the slip and slide method. I think it's a little shorter. But if I could not factor it, I would use the quadratic formula. But I'm going to factor it. And so when I factor this, I could, I'm just going to bring down the entire equation first. The first thing you want to do, using the slip and slide method, you're going to slip your a term down to your c term and multiply that. And I'm left with x squared minus 16x plus 15. And I'm going to bring down a 0 eventually when I get my two binomials. And then the next thing I want to do is factor this expression here. So I want to find two factors of 15 that have a sum of -16. So that would be x minus 1, so -1, x minus 15. Because when I multiply -15 and -1, I get +15. But when I add it, I get -16. Now, so same factoring that we always do. Then I want to slide down whatever I slip to the end. So this 3 here is what I move to the end. I'm going to divide my factors by 3. And I'm going to reduce if I can. If not, I want to slip that 3 to the front of my binomial. So 1/3 here, I cannot simplify that anymore, so I'll move it to the front. Slip it to the front. So that's 3x minus 1. Here I could simplify this. So that would be x minus 5. 15 divided by 3 is 5. So I factor this equation. And it says one of the solutions is 1/3, right? So of course right here, if I were to solve this, 3x equals 1, that's one of my solutions. So I know I'm on the right track. So my other solution would be, I set x minus 5 equals 0, And of course, it's just going to change the sign. So x is equal to 5. All right. But again, solve quadratic functions using any method that you prefer within reason. All right. So, but you can always use quadratic formula. All right. If we look at number 51, what are the solutions here? We don't have 3 terms. We don't have difference of squares or anything so that we can factor. But I'm going to actually move. Well, I could solve this 2 ways. I could divide by 6 and then use like exponent rules, or divide by 18 and then use exponent rules. I'm not going to do that. I could move this 18 over. 6x squared minus 18x is equal to 0. And then I can just factor out the greatest common factor and set those factors or those terms equal to 0. So between 6x squared and 18x, the greatest common factor is 6x. Alright, so if I factor out a 6x, I'm left with x minus 3. Right? And I can set each one of these equal to 0. 6x equals 0. X minus 3 is equal to 0. Of course, if you just divide by 6, 0 divided by 6 is 0. I'm going to add 3. So 0 product property. X is equal to 3. So my solution is D for this one. And I could have solved it a different way. Like I said, I could have divided both sides by the 6x squared, but either way you're going to get the same answer. Alright, so let's take a look at number 52. We have a nice word problem here. It says the height in meters of a projectile can be modeled by this expression here. T is the time in seconds the object has been in the air. V is the initial velocity in meters per second. S is the initial height in meters. A soccer ball is kicked upward from the ground, that's important, and flies through the air with an initial vertical velocity of 4.9 meters per second. Approximately after how many seconds does it land? And so we're looking for seconds, and so we have to solve for time. So this is a quadratic equation because I have this t to the second. So I'm just rewriting this expression from the top here. And I'm going to plug in my given information and solve. Alright, so kick from the ground. We set quadratic functions equal to 0. Alright, t to the second. That initial velocity is 4.9. And initial height would be, S is the initial height, is 0. Started from the ground, upward from the ground. Alright, so I don't really need that 0. So I could actually solve this by factoring. 0 has no value. So if I do this, right? I just did that so you're not like, where did the S go? I could factor out a t. If I factor out a t, I'm left with negative 4.9 t plus 4.9 on the inside, because I took away one of these t's and this t here. So now I could just set each one of these terms and this binomial equal to 0. So here I'm using the 0 product property. So same as just solving using greatest common factor, I just have decimals. So here, set this t equal to 0. Alright, so just like we are, let me give myself a little more space. So t equals 0, so that is one of my solutions. And then, again, I'm just using 0 product property. I didn't mention that before because I just factored. We just have decimals, so it just looks a little different. Alright, and so I'm solving this. Subtract 4.9, and I forgot this negative. Let me not forget that. I had a negative here. Alright, so negative 4.9t cancels out. And 0 minus 4.9 is negative 4.9. And look, I'm going to be left with a nice whole number here. Dividing by 4.9. I'm left with t is equal to negative 4.9 divided by 4.9. That is 1. not t. That is 1. All right, so my answer would have to be 1. Why can't it be 0? Because it says after how many seconds. It would have to take at least some amount of time. It can't be 0 seconds. So I would choose the positive answer. Or if I would have gotten like a negative number right here, when you're solving these type problems, you're going to always choose the positive answer because you can't have a negative time there. So my answer to this equation is 1, or this problem is 1 second. All right, for 53, we have more word problems involving quadratic functions here. So let's go ahead and take a look at it. It says a batter hits a ball upward at an initial speed of 96 feet per second. After how many seconds does the ball hit the ground? Use the formula h is equal to rt minus 16t squared, where h represents the height in feet and r represents the rate in feet per second. So again, I'm just going to rewrite this problem here. All right, and let's fill in what we need. It says again how many seconds, so we're going to solve for time. Initial height would be 0. My rate is 96 feet per second, so that is my rate. I'm going to plug that in for r. And that's it. I could solve this by factoring. So I could factor out between 96 and 16, they both have a t in common, or a 16 in common, and they both have a t. So greatest common factor is 16t. 96 divided by 16 is 6. I took out the t. And 16 divided by 16 is just 1, and I took away one of the t's. So again, just factoring. This looks a little different. And then I want to set each one equal to 0 here. So 16t equals 0. 6 minus t equals 0. All right, solving. 0 divided by 16, of course, is just 0. And I'm solving for t. And since that's a negative t, I divide through by negative 1. So t is 6. So my time here is 6. Okay, number 54. It says a company's monthly profit, P, from a product, killing us with the word problems here, from a product is given by this expression here, where X is the price of the product in dollars. What is the lowest price of the product in dollars that gives a monthly profit of $15.50? And so rewriting this expression, P is negative x squared plus 105x minus 1050. All right, so profit is 1550. So I'm going to plug that in for P. And quadratic function, looks like I'm going to be able to solve this by factoring because I have some 5s and 0s at the end. All right, so remember with quadratic functions, if you want to solve by factoring, move everything to one side. It should be equal to 0. So I'm going to move my x over so it is not negative. So that would be positive x squared. I'm going to move the 105 over. So that would be negative 105x. I'm really adding, just doing inverse operations. Okay, so it cancels out, right? And then I'm adding 1050 to both sides. And this is my like term here. So 1550 plus 1050 is actually 2600. All right, let me write this a little neater. So x squared minus 105x. Well, it's not that much neater. I've been doing math practice test questions for days. So, all right. So I've moved everything to the left-hand side. X squared and 105x becomes positive because I moved it over, and then I just added the 1050. So now I'm left with nothing on my right-hand side, and it equals 0. I can solve this by factoring. Factors of 2600 that equal 105, 40, and 65. When I add them together, I want to be able to get a positive 2600, so they both would have to be negative. because I want negative 105. And then I just set each one of these equal to 0. So x minus 40 equals 0. So x equals 40. And x minus 65 equals 0. So x equals 65. So it says, what is the lowest price of the product in dollars? So what would my answer be? Of course, it would be 40 because 40 is the lowest number here. So my answer to this problem would be 40. So number 55 here, it says the graph shows T, the temperature of water, in degrees Celsius in a test tube after m minutes of an experiment. Drag a label to each box to correctly identify the type of rate of change between the temperature and time on each part of the graph. So we only have 2 here. We notice we have 4 different items that we could choose. So of course on a computer you would just drag these boxes here. So first down here we have a line here. So line is linear function. So a linear function has a constant rate of change. And of course on a computer you would just drag it. So use constant. And not to say that we couldn't use that again actually. So I shouldn't have marked that out. Oh no. Alright, number 56 here, it says an equation is shown. It's a quadratic equation. The formula x equals negative b plus or minus square root of b squared minus 4ac all over 2a can be used to solve the equation. Hopefully you know what this formula is. It is the quadratic formula. So we're going to use this formula to solve this equation. So in the quadratic formula, remember everything needs to be moved, or when you're solving, you need to move everything to one side. So I'm going to subtract 1 from both sides to get everything to one side. So that's 3x squared plus 7x minus 1 equals 0. Now I can identify a, b, and c. So a is your coefficient of x squared, which is the number in front of your variable there. B is 7 and c is your constant. So that would be negative 1 because we have a minus. So I'm just going to take this information and plug it in. X is equal to negative b, so that will be negative 7, my b is 7, plus or minus the square root of b squared, so that would be 7 squared minus 4 times a is 3, and c is negative 1, all over 2 times a is 3. So from that point I just simplify, or from this point I simplify. Bring over my negative 7. Okay, 7 squared is 49. And I look at this 4 as a negative. So multiply negative 4 times 3, that's negative 12. And negative 12 times negative 1, that is a positive 12. So always look at that 4 as a negative, and that way you don't have to deal with double negatives. Alright, at the bottom I'm left with 2 times 3. That is 6. Negative 7 plus or minus 49 plus 12, that is 61. Alright, over 6. So I could leave my answer like this. So it just depends on your test, how they want you to put your answer. You could break it up this way. Negative 7 over 6 plus or minus the square root of 61 over 6. Or you could break it up in a negative 7 over 6 plus square root of 61 over 6, then have another answer, negative 7 minus square root of 61 over 6. Either way, it's the same answer, so just depends on how they want you to put it on your test. As I mentioned earlier, it could be this. That could be one of your answers, and then you could write it the other answer with the minus. So if it wants you to put it as 2 separate answers, you would just put a plus and a minus. Or if it asks for the decimal, you would just take the square root of 61 and then just add that to, you would do negative 7 plus whatever the square root of 61 would be, divided by 6. Then you would do negative 7 minus whatever the square root of 61 would be, and divided by 6. So several ways you can write your answer, just depends on what the test asks for. But that is pretty much how you do the quadratic formula. Let's take a look at number 57. It says in a school of 200 students, 80 students are in the band, 160 students are on sports teams, and 60 students participate in both activities. How many students in the school are neither in band nor on a sports team? So we can use this Venn diagram here to kind of help us out. So first I'm going to start out by putting, it says 60 students that participate in both activities. All right, and then it says, because this is where it crosses over with the band and the sport, so 60 are in both. Now let's go back. It says 80 students are in band, and so if we have 60 here that are in band, another 20 here we have to have another 20 here to make the total of 80, right? And then it says 160 students are on sports teams. So if we already have 60 in the middle here, that would just make another 100 students that are on sports teams. So 60 plus 100 is 160, and 60 plus 20 will give us the 80 for the band students. So a total of 200 students are in the school. So we want to find a number of students who are neither in band or on a sports team. So we have a total of 160 sports. Well, right here we have a total of 160, right? And then we have another 20 here that is left. So that's all of the students. So that is 180 students. So out of 200 students, we just have 20 left. So I just subtract 200 from 180. And so I have 20 students who did not participate in either sports or band. Let's take a look at number 58. It says the points on the graph show the population data in millions of the state of Florida for each decade from 1900 to 2000. The data are modeled by the function p of x is equal to this function here shown on the graph. What is the domain of the graph of p of x that is shown? And so remember domain, you're looking at the distance, you're looking at your x-axis to find the domain, and so we want to see how much space this graph actually takes up on our x-axis. And so it starts right here at 0 on our x-axis and it stops here. And so that would be at, looks like it's going to be at 10. So it goes from 0 to 10 on our x-axis. So that would be x is greater than or equal to 0, but less than or equal to 10. So our answer for this problem would be D. All right, number 59, almost done. It said, let C be any constant number. Which of the following will always be perpendicular to negative 3x plus y equals 2? So first, this equation is in standard form. We want to rewrite it in slope-intercept so we can see the slope. So to rewrite it in slope-intercept, you just solve for y. So anytime you want to find the slope of a line, you just solve for y to write it in slope-intercept. So we're left with positive 3x, and you want to put the term with the x first. Plus 2, because we can't combine them because they are not like terms. So this equation in slope-intercept form is y equals 3x plus 2. So our slope is 3. The perpendicular slope would be the opposite reciprocal. So we flip the sign and flip the fraction and change the sign. All right, so since we have an understood 1 under the 3, we flip it, that would be 1/3. The 3 is positive, so that would make it negative. So I'm going to say this is the perpendicular slope. All right, so we want to find which one actually matches, and we actually have it right here. We don't have any other, they're already in slope-intercept. So this one here has a slope of negative 1/3, so this would be always be perpendicular to this line here. Alright, so we finally reached the very last problem of our practice test, so let's go ahead and get started on number 60. It says, what is the slope of a line that passes through the point negative 1, 1 and is parallel to a line that passes through 3, 6 and 1, negative 2? And so what do we know about parallel slopes? That they are the same. And so if we just found the slope using these 2 points here, that will give us the slope of the line that would pass through this point because it would have the same point. So we're given this ordered pair, but we don't need it because if we just find a slope using these 2 points, that would be our parallel slope because it would be the same. So slope formula right here, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Labeling, let me just erase some of this here. So x1, y1, x2, y2. Plugging it in. Y2 minus y1, that would be negative 2 minus 6 over x2 minus x1, 1 minus 3. Negative 2 minus 6 is negative 8. 1 minus 3 is negative 2. And that reduces to a positive 4. So the slope of the parallel line would also be 4 because it is the same slope. We've reached the end of our review. I want to thank you for reviewing with me. Some related videos are parts 1 and 2 of the Algebra End of Course Assessment Practice Test, as well as Geometry End of Course Assessments if you want to take a look at that to see what your test may look like next year. If you haven't already, please like, comment, share, and subscribe, and please click the bell so you can be notified whenever I post new content. And once again, I want to thank you for reviewing with me.